So in one of my previous videos, I asked you guys a question, and that was to determine what a graph of the change in angular momentum versus theta would look like in an experiment where you have a flat horizontal rod fixed at one end, or it's allowed to rotate on one end, and you have a projectile that's shot with increasing angle theta, and it hits the end of the rod. And for the graph shape of L versus theta, what is that graph shape going to look like? Here's your answer. So if you graph the change in angular momentum versus theta, it's going to look like part of a sine graph. And the reason for that is, let's consider what is going on here. So if you have a collision, we automatically want to think conservation of momentum. So whatever angular momentum that projectile initially has, that momentum is going to be transferred to the rod during the collision because momentum is conserved. So your total initial momentum equals your total final momentum. And if we want to consider then what is the angular momentum of the projectile, we're going to use the equation R, so that's like the length of your lever arm, m, the mass of the projectile, times v, its speed before it hits, and this times the sine of theta, because the angle between that velocity vector and the lever arm is important. And the smaller that angle is, the smaller the change in angular momentum of the rod will be. So say, for example, you were to hit at a 0-degree angle. That's like not really a possible thing, but you would have no change in angular momentum. If you had like a 10-degree angle there, that's very small. You have a very small perpendicular component to that velocity vector. But as you get toward 90 degrees, the sine theta is going to increase. So generally we'd be looking for a graph that's showing an increase. As theta goes up, L will go up as well, but it has to look like a sine graph, because if we look at that equation, L is proportional to the sine of theta. So if we're graphing L versus theta, our graph is going to look like a graph of sine theta.